Hello, everybody. Thanks for coming today. My name is Chris Prince. I'm an engineer on the Gears project. And I just want to start out by saying that we're really excited to be launching this today. I'm especially excited just because this is kind of my baby. I've been working on this with the team back in Mountain View for a while now. And it's really great to kind of see your project go into the world and see how people are going to receive it. Yeah, this is definitely a very special day for us. And we're happy to be releasing it to you all. So at a very high level, what is Gears? You've probably heard a little bit about it already, but basically we're talking about a set of JavaScript APIs that web developers, like yourselves, can use to offline enable their applications. And like everything else at Google, this is a beta launch. And also like everything else at Google, this beta launch is maybe a little bit more robust than you might otherwise expect. And so just to kind of show you what I mean, Reader is an application that launched with Gears support just today. So let me show you a quick demo of what they've already got working. Just to kind of prove it here, I'm running offline. And you can see that even though I'm offline, everything works just like you'd normally expect it to. So I can switch between my RSS feeds. I can mark items as read. I can tab through them. I can do all the normal stuff, mark things as starred, navigate around the UI, back and forth. And it's actually pretty zippy, too, just because I'm actually hitting the local database instead of doing a round trip to the server every time. And then if I connected, all of my data would automatically get synced back to the server. So as I said, even though we're doing a beta launch today, this API is definitely ready to be used by you, the developer. And we definitely want to get your feedback on what works and what doesn't. So I think a good way to start out is to ask ourselves, well, offline sounds great, but what if I'm not a frequent flyer? What if I'm not always spending my time on an airplane? Do I really care about this? And I think the answer is yes for a few different reasons. So first of all, let's consider the best possible case. You have a very fast home broadband connection. All right, well, you're not always at home. You're going to hopefully go outside once in a while, get a cup of coffee somewhere. Maybe you're on a subway and maybe you're in the countryside. There's a lot of cases where you just don't have their home connection. And for those cases, you'd like to not have to think about actually finding one and doing all the connection work. So that's one reason that it's actually important to have offline-enabled applications. The second one is performance. So the speed of light is really what kills us here. Even on a perfect scenario, you're going to incur a couple 100-millisecond round trip time to go to the server, come back. And if the application you're using requires a couple round trips, it's even worse. So that pretty quickly adds up. And it doesn't seem like a lot, but it really hurts the user experience if you've got to wait for these delays every time you take an action. And the third thing is that even though we've got very good connections, there's always times when the phone company is doing work on the connection, or it has to take it down, or your wireless router has to be rebooted. And so you really don't have 100% uptime. And it can be annoying when these things go down. And so if you just didn't have to think about it, that would be great. So actually, Gears, like most projects at Google, started out with a lot of engineers kind of thinking to themselves, wouldn't it be cool if X, and in this case X was if we could create offline-enabled web applications. And so we started asking ourselves, well, what would this look like? What do we really want this to be? And so the first thing we realized was we wanted it to be totally seamless when you were transitioning between offline and online. We didn't want you to have to think about, all right, well, do I have a connection now? Let me try to connect. Oh, crap, it's not up. Let me disconnect. Oh, let me try again. It's just a terrible experience for the user. That also means that you have to have a single URL. If you have two different URLs, one for the online version, one for the offline version, you have that exact same problem of flipping back and forth between modes. It's just a bad experience. The other thing is that we realized one of the powerful things about web applications is that we don't care where we are. We can go to any computer, any operating system, any browser, and we can access our data. We can use our files. We can create content. It's great. And so for Gears really to be interesting and powerful, it also had to work across all these different platforms that we might use web apps on. And finally, we realized pretty quickly that if you can use the local machine's resources, even for an application that you don't care about using offline, it's pretty addictive. So you start realizing that those couple 100 milliseconds, when they disappear, actually create a much better user experience. And so we realized it would be pretty hard to go back to non-offline enabled applications, even for the cases when we're online. So those are our goals, a pretty steep set of requirements, but the things that we thought would be the right way to approach offline enabled applications. So if you think about the spectrum of really any application, you've got on one end web apps, AJAX apps, and on the far other end you have native desktop apps. And what we're talking about here is really something in between those two endpoints. And the question we had was, well, where in between does Gears really fit? If it's right in the middle, that has a few problems. It means that, we're talking about a pretty radical shift in how people develop applications. It doesn't seem good because now people need to throw away all they've learned about AJAX development. People need to throw away their great tool sets they have. There's a lot of knowledge that's been accumulated, a lot of momentum. And it seems silly to not keep that going and take advantage of that. So we decided that really Gears should be very, very similar to what AJAX apps are today. And really, we really much wanted it to be an incremental improvement over current web apps. And so that's what we made it. Gears is really an incremental approach to supporting offline in web applications. You've probably noticed, like I have, that the network connection is a little bit slow today. So we're waiting for each slide to load. Well, you wait. It may be in a couple slides. So we'll go to the backup plan here. All right, so like I said, this really is an incremental approach. And the way we've implemented it is as a browser plugin. So in the case of Firefox, it's an extension. In the case of IE, it's a BHO and a browser extension. We do support all the major platforms that we wanted to support. So Gears works across Windows, Mac, and Linux. It works on Firefox and Internet Explorer. And other browsers are coming down the pipe. So Safari's in the works. Opera will be in the works as well. We decided that we wanted to make this open source, and there's a few reasons this is important to us. And a big one is security. We know that it's really important for any browser extension or anything that's related to web apps in general to be bulletproof. As users, that's important to us. As developers, that's important to us. And so the more set of eyes that are looking at this code and finding problems with it and fixing those problems, it's nothing but good things for developers and for end users. The other thing is that we know this is going to be an incremental approach, and we're going to revise things over time as we figure out what works and what doesn't. We definitely want feedback from you, the community at large, to figure out what should we add to this set of APIs. What works well, what doesn't quite work well, what should we change? And so we definitely want your feedback, and open sourcing seems like the best way to get that. And we hope that what we're doing here is providing a set of fundamental building blocks. This is definitely aimed at offline applications, but we're hoping that by making these things not too specific, that this will really be for web applications, kind of what XHR was for AJAX apps the first round. So then it's worth asking ourselves, well, in a perfect world, kind of what does an ideal Gears application look like? And I think the right model that we've found after a lot of trial and error is your application reads and writes to the local database instead of going directly to the server. And then all these changes that you've queued up are opportunistically pushed to the server when you have a network connection. So you've got another little engine running in the background, taking data out of the database, pushing it up to the server, and taking new changes from the server and putting it down in the database. This seems to work out really well for applications. So it's worth asking ourselves, well, what about my application? What do I have to do to make it offline enabled, starting with what I have today? So this is a pretty good model for what applications today look like. We've got our client, which is a UI component. It's using XML HTTP requests to talk directly to the server and pulling down changes directly from the server. The Gears approach isn't all that different. It's actually a very minor change. And the way it works is that now the UI is talking to the local database. And the one addition is this little red sync engine part. So now we've got this little piece of code that's pulling data out of the database. And where we would have been talking directly to the server from the UI before, now we're using the database as the source of that data and the place where we stick data that comes down from the server. So again, a very incremental approach. We don't want people to have to dramatically rewrite their applications and start from scratch. We want to kind of do just what's required to add offline capabilities to web apps today. So OK, we kind of at this point figured out what we wanted the APIs to look like and the feature set and how the application should work. So then it was a pretty simple thought experiment to say, all right, so exactly what APIs do we need to provide? So the first thing you say is, all right, I want offline enabled reader. Well, I need to be able to type in reader.google.com in my browser, and when I don't have a connection, I need to get back HTML and JavaScript files. And that's what the local server does. It basically maps URLs to content on the local machine and serves up that content when those requests come through. All right, so at this point, we've got a lot of HTML and JavaScript we're looking at, static content. Now, when the user reads something and wants to star an item or mark it as read, we need some way to remember that and then send it back up to the server later. So for that, we have a database. We felt like a database was important, something richer than just key value pairs. If you start looking at more complex applications, you realize that the simple stuff doesn't quite cut it. You really do need the power and flexibility that a full database provides. All right, so now we can store the user's changes. We can look at the static content. When we reconnect to the server, we're going to push it back up. But if we're talking about a large amount of data, if we're talking about a lot of photos, for example, or a large bulk of email that's come in since I was last online, then we need some way to do this without blocking the browser. And so that's where the worker pool comes in. This is a way to run very time-intensive operations in the background without interfering with the browser responsiveness. So let's just look at each of these components in turn and go into a little bit more detail. Like I said, the local server is aimed at running web applications online, serving up URLs, serving up content based on URLs that come through. And I think the best way to think about it initially is imagine how a browser cache works. You know, it's the same idea. It's pulling content locally, serving it up to the browser. There's two key differences with how a local server works. And the first one is that these resources are always going to be served out of the local cache. We're not going to try to hit the network and just fall back to it. And that turns out to be really important because if we didn't do this, you actually get into very subtle, odd situations where the application gets out of sync. You know, say you have a couple JavaScript files, and one gets pulled from the network, and one gets pulled out of the local cache. And now these versions are totally incompatible. Your application just breaks. And the worst thing is you don't even know why it broke. I mean, it just kind of magically changed and stopped working. It's terrible to debug, and so we wanted to make sure that that wasn't going to be a possibility. So there's two flavors of the local server. The first one is the resource store. And what this lets you do is capture single URLs. And at first glance, this seems like exactly the right model you want. You want to say, all right, you know, I'll give you a list of the URLs. One by one, I'll call this function. I'll tell you what content to capture and what URL to serve it up for. But again, you have this problem where pretty quickly, in some weird corner case, you find a subtle bug where you have resources that are slightly out of sync. And so for that reason, we also provide the managed resource store. And this is what we recommend application developers use to capture their applications as a whole. So the resource store, how does that work? Pretty much exactly like you'd expect. You pass in a URL that you want to capture, and when that resource has been captured, you get a call back and saying, hey, it's done. This is still useful. I mean, you don't want to use it for your application as a whole, but for some things it can be handy. It's like, say, attachments or individual pictures and photos. So there still are cases where you're going to use the resource store. But for the common case and for capturing your application as a whole, you really want the managed resource store. And the way this works is you're going to list all the resources that your application needs. And it can be anything. It can be HTML files, JavaScript files, Flash, and so on. And you're going to put those in a manifest. And you have some user-defined ID for that manifest file. And that's basically the version number. Whenever that changes, Gears is automatically going to pull down the new contents of the file. And then only when everything's available locally is Gears going to flip the switch and start serving that new content. So if you think about it, this pretty closely matches what happens on the online world today, where you push a new version of your application to the server, and then you flip a switch on the server, and people start getting those new files. We're doing the same thing, but just locally. The other thing that's important to point out here is that we do want to provide the same kind of functionality that you get with online applications. And one of those bits of functionality is serving up different content for a given URL based on a cookie value. So you know, if I have user 1 that logs in and expects the English version, and user 2 logs in and expects the French version, both for index.html, online I would toggle that based on a cookie value. And the managed resource store lets you do the exact same thing. You can toggle different content based on a cookie value. So I think it's interesting to look at a bit of code and just see, you know, if I'm waving my hands here or if this is really as simple as it sounds. And hopefully you'll see that the answer is it's pretty much as simple as it sounds. So this is kind of how every Gears object starts out. We have what's called the Gears factory. And we call a create function and say, hey, I want to create a new instance of that object. You're going to see this a couple times during the presentation. And I pass it a name of the object and a version number. The version number is used so that we can do two things. We can provide new incremental features over time. They're not backward breaking. And we do that by bumping up the minor version number. So if you know you require the features that were added in 1.1, you can go ahead and request that. At the same time, we'll bump the major version number if we ever make a backward incompatible change. And we'll continue supporting the old 1.0 version numbers as well. So this is an easy way for applications to get the features they need, but without breaking people that, I mean, obviously, all the applications on the web are not going to all bump their version numbers at the same time. All right, so once we've created that object, we give it some user-identified ID. This just helps us keep track of things in the system. And then it's as simple as saying we want to set the manifest URL to some URL. And this is going to be a JSON file, very simple format shown below here. We have a version number. Like I said, this is totally application defined. Whenever this string changes, Gears is going to pull down the new manifest file and the new versions of the resources and flip a switch when everything's been pulled down. And then I just list the resources that my application needs. In this case, I've got an HTML file, a JavaScript file, and one image. So let's see if we can force this to work online. Because if you think about it, this presentation itself is really just a form of a web application. I've got an HTML file, a set of JavaScript resources, a couple images. And so why not make this presentation itself offline enabled? So I've done exactly that on this slide. When I click this link, I was basically doing what I just showed. I was telling the system that I have a manifest file, that it's got all the resources that my presentation needs. And then Gears is going to go to the server and start pulling down those things one by one. And of course, in this case, because it's in front of a large audience, it's going to do it very slowly. And what you would see is if this were a decent network. See, the problem is you guys are all downloading Gears right now. I know that's what's happening. So this would finish downloading, and then I'd be able to actually pull out the network cable and go through the presentation. All right, so the second component is the database. And like I said earlier, we really want to make sure that we provide something that's rich enough for web applications. Key value pairs really doesn't cut it when you start dealing with more complex stuff. And so we found that the full power of SQL was really what worked out pretty well. There's a couple of different implementations of SQL that you can get and embed in applications. And there's one called SQLite, which actually meets our needs very nicely. And for a few reasons. One is that it's very tiny. It's only a couple of 100 kilobytes in size. It's also really mature. People have been using this in a lot of different applications, even in the embedded space and the mobile space. So very mature, very fast. And the other thing that we love as Google is that it scales to gigabytes of data, because we get a warm, fuzzy feeling whenever something scales to gigabytes of data. So SQLite was the way to go for us. I think the other thing that's worth mentioning here is the security model that Gears uses. So it's a strictly same origin model. And if you're familiar with how cookies work, this is actually a little bit more strict than that. Basically, a site can't touch a database or any URLs that belong to somebody else's origin. And what I mean by origin is not only do the domains have to match, but also the protocol has to match, so meaning HTTP, HTTPS, file, and so on, as well as the port. The port has to match between the two sites. If any of those don't match, you can't touch those resources. And this is really done, again, for security reasons. We want to make sure that sites are sandboxed from each other. As an app developer, I don't want some rogue site to decide that it wants to capture a fake version of my homepage. And as a user, I don't want applications to be banging on each other's resources or have evil.com be able to access all my mail or all my RSS feeds or whatever. So again, a quick code example. This should look pretty familiar. Again, factory create, we pass it the name of the object and then the version number. And then if any of you have done any SQL programming, this should look very familiar as well. So I'm going to insert an item into a table. I have a table called Tasty Foods with two columns, one for the name and one for the number of stars. And because bacon is my favorite food, I'm going to insert bacon with a 5-star rating. And then I'm going to iterate through this table, and I can get all the results out and start printing them out to the screen. And it's just as simple as that. It's a couple lines of code. I think you can see that there's not a whole lot of overhead on top of the SQL itself. It really lets you get the full power that you need for your application. So this application is itself database driven. Let me go ahead and capture the offline version. And of course, I'm not online, so I can't capture it from the server. But what I can do here is I can see the content that's stored in the database files. So if I say select star from slides, here are all the titles of my slides as I've been going through the presentation. And I left off right here on 15, demo database. So the cool thing is this is really interactive. I can update this on the fly. So I can say update slides, set title equals updated in real time, where ID equals 15. And now when I go back, the slide's actually been updated. So you can see that this is really coming out of the database, and this really is a Gears-enabled presentation. That tool I just showed you, that DB query tool, that's something we provide with the SDK. It turns out to be really useful when you want to debug what's actually in your database, what the contents are, kind of what your tables look like and all that. There's also a set of third-party tools as well that are pretty useful for debugging SQLite stuff. So the third component that we're providing with the Gears SDK is called the worker pool. And this is a way to run JavaScript code in the background. I think as web developers, most of us are familiar with how, in certain cases, browsers are single-threaded. And it's not uncommon for a certain long-running operation to actually freeze the browser to make it kind of unresponsive, or it's a really bad experience for the user. So the idea of the worker pool is to avoid that, to get rid of that limitation, and let you run arbitrarily long computations as you need to, without popping up that dialog that says, hey, unresponsive script. So as developers, we also realized, wow, threading is really hard. There's a lot of nasty problems to deal with. There's synchronization. There's making sure that you don't deadlock. It's a pain. So we chose a slightly different model for handling these workers. And it's really more of a process model than a threads model. So when you spin up a worker, you pass it the full body of code that you want to run inside that engine. And then you communicate to and from it using strings. And you can also pass richer data types by serializing those data types into strings using JSON. So it's not too limited. You have a lot of flexibility for how you want to handle the communication. And it also gives a very nice synchronization model. You don't have to worry about these weird corner cases when you're dealing with threads. All right, so one more code sample. Let's say we have some function that computes prime numbers. And I had to remove the algorithm because of US export restrictions, or just because it was too long. And then we're going to create an object. We're going to create a worker pool this time, version 1.0. And it's as simple as saying, all right, whenever you receive a message from somebody else, call this function. And in this case, what I'm going to do is I'm going to throw up an alert. You would do something more complex in your particular application. And then to create this worker, all I do is pass it the body of code. In this case, I call string on the next prime function. And I execute it once. And that's all there is to it. So let me show you a quick example. There's this concept called prime quadruplets. They're basically groups of 4 prime numbers that are very close together. And computing these things takes a little while, because there's a very expensive algorithm for n-squared going through and finding all these things. And so if I click on the demo, let's go ahead and do this as a standard web app, not Gears enabled. And as you can see, these things start chugging along and starts computing the numbers. And it's not too bad, but then pretty quickly, as each iteration takes longer and longer, you can see my slider bar here starts getting pretty clunky. And not only that, but if I needed to change between tabs or create new tabs, you can see it's taken on the order of seconds now to get between these things. Let me stop that before I die. All right, so now let's do the same thing, but on a worker pool. And now this time, you see the speed of computing the numbers is the same as it was before, but the slider isn't getting chunky like it was. And even though I'm getting up to the same number range, I can still smoothly move between tabs. There's no problem there. I can basically do anything I would normally do. I can even kick off another one of these guys. So I've got 2 of these going at the same time. My CPU is totally pegged at this point. But from the user experience perspective, I don't care. I mean, you can see this bar is still moving smoothly, and I can still move between tabs without problems. So I think this is a pretty cool feature. It's going to hopefully avoid a lot of the problems that, as users, we've seen where web applications are locking up the browser. So I really don't think that any Google presentation is complete without search, because, hey, this is Google, right? So we have this little feature here at the end where we can type in words that we've seen before, like bacon, for example. And you can see the slides and a little snippet from the slide in the URL. And we try Gears. hold this to slides as well. And the way this works is we have a full text feature, which is on this bonus slide. This is something we've added to the SQLite engine that comes with Gears. And it's basically a joint project with the SQLite team. It's a way to support full text search. It's done through a concept called virtual tables. And the implementation we have today, called FTS2, supports millions of documents. We're in the design stages of a next iteration of it that's going to support tens of millions of documents. And we're also looking at ways to support additional languages. Today we support EFIGs, English, French, Italian, German, Spanish, and we'll be supporting other languages over time. So we're pretty excited about this. We think this is a pretty exciting addition to the SQL engine, and will come in handy in a lot of cases when your application's offline and you still want to provide search capabilities. So that's basically what I wanted to present. I also want to give you guys a lot of time to ask questions that you might have, because I'm sure that will be a big part of things. So definitely, if you get a chance to, visit gears.google.com, try out the SDK, and please, please let us know what you think. Let us know what's broken, what works well, what doesn't. We look forward to your contributions, whether they're patches, bug reports, just suggestions, whatever. So we're very interested in community feedback. We expect that this will be an ongoing process, and hopefully over time we can get a very stable set of APIs that people will start using at a wide scale. So with that, I'll open it up, and thank you.
Couple of questions. One, I don't think you said anything about security or sandboxing, so if you could just describe how you handle that. And secondly, what about the amount of space that one can take up in local storage? Is there any limitation on that, or can you just fill the user's hard disk with huge SQLite databases?
Sure, good questions. So the first one, in terms of sandboxing, how we support that. Basically, any script that's running, we know what URL it comes from. And so we use that URL to figure out what the origin is of that page. We associate an origin with it. And then in the internals, we make sure that whenever you're opening up a database or capturing URLs, that you're never crossing that origin boundary. So that's how we handle the sandboxing between two sites. As far as the amount of space that an application can use in the database, so today it is unlimited. And I think the way to think about it is by opting in to have an application use Gears, you're in some sense installing that application. And so just as today with the desktop app, if you installed that application, it can use an arbitrary amount of space. You're kind of saying, I trust this app, and go ahead and use whatever space you need. Now, if that turns out to be the wrong decision, and developers tell us, hey, we really think we need some kind of quotas on this, then yeah, I could easily see that becoming a feature that we add over time.
Hi, a couple more security-related questions. One is there going to be any form of encryption so that I can encrypt the data that I'm storing locally? And secondly, you just showed us that very neat, very easy to get to tool for updating and looking at the database. Is there some way to stop that so that your users aren't maliciously or accidentally messing themselves up?
Yeah, so as far as users messing themselves up, I mean, I think that's an unavoidable problem when you're talking about anything running on the desktop. The user really has full control over their own system, and so if they really want to, they can shoot themselves. There's, I think, very few users that want to shoot themselves, especially when it's their data that they're talking about. And so I don't think that's, in practice, going to be a big issue. The other question was about security of
encryption.
Oh, the encryption, right. So we don't do any encryption today, and we thought about this a lot, and whether we should do it automatically. There's a couple problems that come up when you think about how you want to handle that. If you require the user to enter their password and use that password offline, then somebody could pretty easily run a dictionary attack on the machine and figure out, kind of reverse engineer what their password was. If you require a second password, well, a lot of times people aren't going to choose a different one. They're going to choose the same one. Or if they do choose a different one, it's probably going to be pretty weak. And it's just a really bad experience. If I have to remember, oh, am I online, am I offline? It kind of goes back to that seamless question. We want it, you want not to have to think about whether you're offline or online. So we haven't figured out a good way to make that seamless. If you have ideas for how to do it, we'd love to hear them, because it does sound like a great idea.
Thanks very much.
Thanks.
With the worker pool, have you got any sort of collision mechanism? So, you've got the data in one central repository, and then you're basically making an alteration to it locally. and then perhaps somebody third party has worked with the live data whilst you've made your change. Have you got any implementation there?
Yeah, so I think the best way to handle collisions of data between worker pools is to use the built-in SQLite synchronization mechanism. You can have the SQLite database opened by multiple connection points at the same time, and internally it knows how to deal with that. And so I think that handles most of the cases that you're thinking about in terms of collisions between worker threads updating the same thing at the same time.
Yeah, well, actually, it was more about them altering it at different times in different copies of the database. You might be running SQL Server, and then you've got SQLite here. And how do you synchronize those two changes?
Yeah, so I think, synchronization is a good question. What we've chosen to do for this initial release is not tackle the synchronization problem. It turns out that we talked to 3 different teams and asked, all right, what kind of synchronization do you need? And there were vastly different answers between the 3 different teams. And there's also people on our group that have worked on synchronization type engines before, and they said, look, we don't even know the answer to this. I mean, in a perfect world, we're not sure how we should handle this. So right now, we're not providing anything. This is up to the application developer today. Over time, maybe there will be something that works for the 80% case. And I think if that happens, it's going to come from the community, from you guys, and kind of seeing what works for applications and what doesn't, and kind of what's mostly good enough.
Okay, all right, cheers.
Hi, you started off with the example of Google Reader. For Google Reader, the state it stores isn't exactly critical. If you lose your reader state because your laptop hard disk dies or something, that's not a disaster. But many kinds of web applications deal with more critical states, such as financial transactions. How do you expect those kind of applications to adopt Google Gears? Is it out of scope for Google Gears? Or do you have some way to manage user expectations about reliability? What are your thoughts about that?
Yeah, so I think that's a good point. Today, I think the right way to think about Gears is as a way to provide extra functionality in the cases where it's not mission critical. And I think for a lot of consumer applications, that is the case. Banking applications are definitely a special class of app. And I don't know that with what we have today that we are providing what you would need for that kind of mission critical robustness. But maybe there is something we can do, and so I would love to know more about kind of the use cases, and maybe we can figure out what works and what needs to be added.
In the meantime, do you have any thoughts about how you manage user expectations? Like, for example, web browsers. Some websites are secure, some are not secure, and web browsers make it pretty clear if you're looking at a secure website or a not secure website.
Yeah. So in terms of user expectation. In terms of what we're providing in the version of the APIs, you can kind of think about it as a very large cookie. That's kind of what the database is. And so in the same way that sites can store cookies on your machine today, sites can, if you opt into it, store stuff in your database. And so we do tell the user, all right, if you opt in, this site may be able to store data on your machine. And we make sure that they make that choice, if that's what they want to have happen. We don't let it just happen in the background. So I think that starts to answer that question about how we make sure that users have knowledge about what they're doing when they use Gears for a site.
Thanks.
Hi there. I'd quite like to look at the worker pool, but especially because it lets you run these long-running tasks without blocking the UI. I was wondering if you can tell me a bit more of some of the other advantages associated with it versus, like in comparison, say, to the Google Web Toolkits. They have an intermittent command. Does the same sort of thing, but without actually requiring a browser extension.
Yeah, so there definitely are alternate models where what essentially happens is you kind of time slice your code. You basically return and then jump back into it and then return again. And the problem that you find is that doing that in an automatic way is really hard, and doing it manually is just very time consuming. So I think that's the key advantage over something like that approach. We did consider something like that, but for applications, it was just a lot of work to try to make sure their function was reentrant and could be time sliced that way. And so the worker pool gives you a way to do that, or get the parallelism, but without having to do that kind of upfront work to break up your function. So I think that's probably the biggest difference between those two approaches.
Yeah, but I think that the like the Web Toolkit's intermittent. Sorry, I'm not sure if it's called intermittent command, but it's a new feature in the 1.4. But it's supposed to do that time slicing as well.
I'm definitely not familiar with that, but yeah, I'm sorry.
Are there any other advantages that with the worker pools that
Well, I mean, it really is meant to support background operations. So, you definitely avoid blocking the browser. I think over time, like with a lot of these applications, we want them, or a lot of these APIs, we want them to be kind of core enough that developers can use them in interesting ways. That's one of the reasons that we didn't really want to provide a sync mechanism for just offline online sync. We feel like providing a database, providing a way to capture URLs and serve them up, and providing a way to do operations in the background is a lot lower level, and it's a lot more the building block approach that people will think of cool things to do with these things that we never imagined. That's for sure what happened with XHR, right? And so in the same way, we figure smart guys like you are going to figure out how to use this stuff in useful ways. So I don't know the answer today, but I strongly suspect that there will be very cool things that people do with workers.
Thanks.
Does Google Gear automatically manage the browser's cache, or does the web developer need to mark the pages as no cache?
Does Gears automatically manage the browser's cache? So not directly. Really think about local server as a separate piece, not tied to the browser cache at all.
So basically,
you can think of it as sitting right in front of the browser cache, watching the URLs go by, and figuring out, should I handle that? And if not, passing it on to the rest of the system.
So there might be duplication of data in the browser's cache.
Yeah, there may be the same URL twice. Sure. Okay, well, if that's it, I'll jump down, and I'll definitely be around if people have more questions later on. So thank you for coming, and like I said, please try out Gears when you have a chance.